Hi, and welcome back to the New Space Vision podcast, sponsored by Lifeo, where we discuss new space technology, finance and innovation with executives, founders, and more exciting people from the startup and new space ecosystem. I am Dani Seidel.
And I'm Sven Shivara, and together we are the founders of the Earth observation company Lifeo and New Space Vision. Today we are particularly excited for the conversation we are about to have, not only because the guest is an alumni of the Technical University of Berlin, just like myself, but our guest is also a symbol of new space who has extensive experience in the biggest private space company of today, SpaceX. In fact, he was their fourth technical hire, interviewed by Elon Musk in his living room before SpaceX had any offices. Serving as SpaceX VP of avionics and later VP of reliability, his role in building early SpaceX hardware directly contributed to its success. Welcome, Hans Koenigsmann, to the show.
Thank you. Good morning.
Today we want to... Yeah, we are extremely happy to have you. Thanks for taking the time. Hans is calling in from California via Starlink. So this is I think the first time for us to use Starlink as a podcast, or have we?
No, I mean we had in one podcast our internet was down and we just ordered Starlink, but that was 3 years ago, and the coverage was not complete, or 4 years even, right, in the old office. Yeah, but the connection is perfect, right?
So, yeah. Every once in a while there's a little jitter, but it goes away right away.
Yeah. There are many books which have been written and films have been made about the early times of SpaceX. Today, what we're trying to uncover is a little bit your personal story and a couple of takeaways people in the space ecosystem can take from the success of SpaceX. We want to start with your, so to say, German heritage. How was the space industry in Germany 35 years ago when you graduated and when Daniel was born?
Right. Well, so I don't remember how it was when I was born, but probably at 63. Probably not. Well, actually, there was some stuff going on, I think. But by the time I went to college or to university, we started up in Tuxtad. So there was like this wave of small satellites, and the small sat conference in Utah, Logan, was just starting up. So there was a time when actually small satellites started. And small meant in this case the size of, kind of like a garbage can size, so smaller, but not as small as today. And so I got interested in that. I worked a lot with Professor Renner from TU Berlin. I then went over to ZARM in Bremen and worked on Bremsat. And enough, Bremsat was actually successful. It flew, and I think we delivered data for the experiments and everything. And then after that, there was basically nothing really. There were satellites going on in the major industry, of course, but for like small satellite people like me, there was really nothing coming. And so I got an offer from someone here in Los Angeles, and I thought, well, 2 years, it's more like an adventure. And so that's why we moved over here based on the work visa and basically looking for an adventure, like so many people in California, I guess.
Yeah, that's exciting. And what Sven mentioned, right? When you graduated, I was born 35 years ago. So, and we looked a bit into also the mission you worked on, right? In this program. So can you explain us a bit, like what you learned? Graduating, you also did a doctor engineer, right? Like a PhD.
I did. I didn't really think so. I actually never had planned for that really. And then at the end, when we finished Bremsat, I realized if I stay 7 years at a university or 6 years at the time, and I don't have a PhD, no doctor, then that looks really weird, right? It looks like I didn't really, wasn't able to do that. So I just did it basically in like 3 months, as an add-on. And so it was more like an insurance in case I come back to Germany, because I thought, middle management is like more open to a PhD, but And here in the US, I don't think it helped me in any way. At SpaceX in particular, I think I never really mentioned that I have a doctor, so people don't know.
Yeah.
And honestly, I mean, there's certainly PhDs and doctors that make a lot of sense, but I think in my case, it just did not make sense.
Yeah, there was a question which we wanted to ask, whether you think it makes sense for young people to do a PhD. So you already answered that.
It depends on the person, obviously. If it's like if you need like a little bit more time to figure out what to do and you're actually interested, might be good programs. Is it important for your career? Maybe some companies want that, but then maybe I wouldn't want to work there.
Yeah. Okay. Well, that's a clear statement. What we've asked ourselves, because we've heard oftentimes that that it's quite difficult to work in the aerospace sector in the US as a non-US citizen, because what we are ultimately talking about is dual-use technology. So was this in any way a barrier for you to enter the industry, and how have you overcome that?
Definitely. So I worked for a small company originally, and things were a little bit they accommodated me basically and worked around it. And there's certain things that I couldn't do, certain places that I couldn't see, but it also got more and more strict as I was here. So at the beginning it was more relaxed, and then things got stricter. But at the same time, I also got I got a green card, and then I got citizenship in 2006, I think. Maybe it was, I don't know, don't remember. Yeah, it must be 2006. So I kind of like progressed in that sense, and I had like probably a couple of disadvantages, but at the same time, it was also that the requirements got fuller and fuller, and so I was just running with the requirements basically. And I personally thought I had always great access. I could do things that I couldn't do in Germany. I always appreciated how, I mean, it was not easy here, but I also imagined what if it's the other way around. I knew how hard it is sometimes to get into Germany and then work there. Easier now too, but so overall, I think it was an experience for me that I don't want to necessarily repeat, but it worked out fine.
Yeah. Okay, good. Well, so for people now moving to the US, it might be a little bit more difficult.
Yeah, it's very difficult. We still work on rocket companies basically as I think it's impossible. And if you have a green card, then you can work there, but then the company needs to do certain precautions so that you need to be shut off from certain file servers, and so it's really not easy, and I'm actually not even sure it's fun.
Yeah. I mean, you moved to the US, and you already said SpaceX was not your first station in the US, right? So there were 2 stations before, right?
One.
Or one. It was blast off,
right?
Yeah,
no, it was actually, so the company was called Microcosm, but they rented me out to other companies. So I worked a little bit. The company that made an impact on me was Blastoff, and I was basically a contractor for them. Blastoff was a company that was part of a bundle called Ideal Lab, and Ideal Lab was like an incubator. They worked with startups. For me, this was my first startup experience. First time working like with desks that are basically doors.
Yeah,
and you can use the hole on the door handle, or the door handle goes for
Cables.
the cable. It's perfect. Just made for that. So that was my first experience working in a really dynamic environment, and I really loved it. I also met Chris Thompson there, among many, many others. And Chris Thompson was one of the first 3 at SpaceX. And so he remembered my name. And that's how the connection basically came together with Elon Musk and SpaceX later.
Yeah.
But also maybe Blastoff was a commercial trial to land on the moon, and there were really significant backers from the film industry. And so it's typical LA, right? It's like film industry and aerospace. It's just like the perfect intersection. And the idea was to show the Apollo hardware how it is now, and it's similar like a technology memorial, like the Titanic to the Apollo, right? And there's a story around that. So it was really I think it was really fun.
Sorry, Hans, could you repeat? Maybe we had a little bit of a bad connection here. Could you repeat from Blastoff was the perfect brainchild between aerospace and the film industry?
Yeah. So Blastoff was the perfect intersection between the film industry and aerospace. Typical LA. The idea was to basically show how the Apollo hardware looks today, and maybe compare this to Titanic, and to tell the story about that basically.
And Blastoff wanted to build the rocket as well as the lander and everything, or what was the intention?
No, Blastoff was building the lander. We bought a rocket. We bought one of the last Lockheed. It was a solid rocket of Athena, I think is the name. And then almost by the time we bought it, the .com crash happened, and Ideal Lab was basically connected to that, and then the company went bankrupt. So also my first experience with that.
Yeah.
I don't know. It was very intense because I had like a terrible commute for half a year, but and I worked a lot. But it was really super exciting.
And maybe one question which we asked ourselves was: you built satellites. How did that help you to build rockets?
Not a lot, actually. Good point. So there's distinct differences in those industries. Rocket people have a certain way of doing things, of routing wires, of putting connectors on, and then the hardware looks like heavy, sturdier. And then the satellite people, they have like really tiny connectors, and the cable look very different, and everything is like fragile. So there's very different differences between the two industries. Some reason I got a little bit into suborbital vehicle work also at Microcosm, and I was basically someone who built up avionics, and I'm not an electronics person. I basically know enough to be dangerous on almost every discipline. And that puts me right in the middle, basically, where you put those things together, and that's often avionics, avionics, software, guidance and control. Guidance and control is actually my background in that sense. And so I knew enough to work, basically integrate the rocket and learn how to whatever is rocket specific too. But SpaceX early on didn't really want people that are very set in their experience. They looked for people that have a little bit of experience, but still an open mind in case there is something you can do better. Because if you hire the entire team from Boeing, all you get is another Delta rocket.
Yeah.
Right.
Yep.
That's true. Yeah. So, I mean, we are super excited to learn a bit also your journey at SpaceX, right, from the early time. And so yeah, maybe can you explain our listeners what was the role you actually had over there and what it means?
You mean over the years?
Yes, exactly. From
Early on, I was the avionics VP, and this was pretty much everything that's not propulsion and structure. Because propulsion was Tom Mueller, structure was Christensen, launch side was Tim Buzzer, and then business was Gwen Shotwell. Yeah. And I was basically everything in between. And I was avionics, software, guidance and control, flight safety, and kind of these glue technologies, basically, that make things work in the end. And I was pretty good in getting a solution together. Although the majority of my time was actually spent in hiring a team for avionics and software. It's very hard when you're a startup to convince people that yes, this is okay, this is legit.
Yeah.
And have them come in, even if the founder has enough money to finish the first couple of vehicles. The other downside is obviously if people don't live in LA, then they look at LA and go, oh, this is like expensive here, and so on and so forth. Yeah, how good is it? So there were lots of difficulties in hiring, and it was slow in the beginning.
Yeah.
I forgot, we were probably in the first year, 2002. I started in May, and I was number 4 technically. We were probably 10 people by the end of the year, something like that. And everybody was just basically recruiting their friends, family, whatever you could find that would work for us. So, okay, avionics first. Later on, I left avionics to Jeff Ward. He's much better electronics person than me. And I was focusing on guidance and control and flight safety for Falcon 9 mostly. Then after that, I became the reliability person for flight reliability, which is the mission assurance basically side. And the background was actually, we weren't really traditionally built, but flight reliability or mission assurance is important when you fly astronauts. And so this was working towards the human spaceflight aspect of Dragon, basically. And then in addition to flight reliability, I got build reliability at one point, and that's basically the quality control. And that has to do with the fact that eventually I worked pretty much all major anomalies. So everything that goes terribly wrong landed on my desk, beginning with like Falcon 1 Flight 3, I think. I was always interested in that. I was always fascinated by how things go, how things can go wrong, and then what do you do to actually prevent them forever. Yeah. And so that's what became my, I want to say, specialty, more or less. And so I worked on everything that blew up rockets.
Yeah, we are also super interested in the flight reliability role. So when did you take this role? So how many launches were already there, or was it before the first launch?
No, I think the first handful launches, I was still working as guidance and control, flight safety. And actually, like still like in this glue position basically between launch site software and still avionics to some extent. Then how did that happen? I think I got the real transition, I think, was after we had an accident with Falcon 9 flight 20, depends how you count, it's 2021, 2009. And I worked a lot on that. And then after that, I drifted over into the mission assurance and flight reliability role.
Yeah. And maybe on that piece, right, you've mentioned that you're interested in all things which can go wrong and when they go wrong to find solutions so that that doesn't happen again. I mean, what you've just explained seems to be an extremely stressful job. And also, like, if a rocket blows up, you need to have a lot of resilience to deal with the results of that. Can you give our listeners and Daniel and myself a couple of tips about resilience, which you've learned at your time at SpaceX?
So I don't know how, I mean, I kept basically my head low and was just like looking at the technical side of that and trying to figure out what the hell went wrong. And it's actually amazing because SpaceX is a really great engineering company. And so they have lots of smart people and you work with an ad hoc team that you put together to solve this problem. So it's a lot of people that I usually don't work with. And it's always interesting to me to basically work with new people and then figure out, oh, they're really smart on this one. And then try to create a situation where you basically work towards a problem and solving a problem. Yeah. I have probably a high inertia, which means I keep rolling. And so it takes a while to disappoint me. But then on the flip side, if I am disappointed, then I stay disappointed probably for a long time too. So inertia is good in this industry. Inertia is generally good for any long-term project. It's actually interesting because I have for like long-term goals I have inertia, but then I'm also very impatient in getting stuff done today.
Yeah.
So somehow that combination worked well for SpaceX. May not work well for other places. So that's basically what I don't know if you can train that. I think I changed over time too, and got a little bit more persistent. If you can train that, that's probably a good trait.
Yeah. And what we also, when Sven and I graded in space engineering, like we could see SpaceX coming up, and in Europe also people always said Ariane way more reliable, etc. than SpaceX. And then you had the accidents, of course, in the earlier times. Now it's the most reliable rocket. Did you back then felt external pressure, or was it internal pressure? A lot.
Oh yeah, a lot. Yeah. I mean, and you do something like that, and they want you to fix it in a week. And there's like tons of outside customers that bombard you with like, what's the status, what's going on, what's the root cause, what's the fix, and so on. And so you got to be a little bit, I guess, just determined to, yes, we will brief you, but give us 2 days and then we do this. So the balance is also on the internal side. Obviously, you need to work as fast as possible. On the external side, you need to be as transparent as possible without giving trade secrets away, obviously. I had started, or maybe I did that later. I started working in media a little bit. I did the press conferences for CES for the launches, and that taught me a little bit to talk to a larger audience and to explain things what happened on the vehicle in a way that people understood it, and also that we what we fixed there. I want to say my overarching principle was always to be as transparent as I could. Explain what did go wrong. Don't try to hide any blame if we made a mistake, but basically show the path forward on how we get to a better place from here. And in almost all cases, we ended up learning things that are really, really difficult to learn. You know, it's all related to basically how stringent your requirements are, how well you test, how well you actually look at your test results, and all of that basically adds up in a quality rocket or reliability rocket. Yeah. And it's just hard to teach this for whole companies. In some way, those 2 accidents that we had were really a blessing because we found stuff that we would have had on the vehicle otherwise when we launched astronauts. So we obviously exchanged those. And then we also taught, how fragile this whole thing is to the company. Yeah. So that's really important. That it basically determines the culture on a company. And you want a company that has a culture that's really and really tries to build the best.
Yeah. And this is also a subject which we wanted to dive deeper on because SpaceX is obviously known for its unconventional approach to risk, unconventional in the sense that Ariane Group would never do such things, often pushing the boundaries, and then this sometimes results in failures. But how do you have any idea how one develops such a system for managing risk? There's balance innovation on the one hand side and safety on the other. And how do you foster this in an organization?
We so early on we had a launch and we actually had a list of like concerns.
Yeah.
And it was concern number 11 that basically described what actually happened. And so we figured, and we actually, oddly enough, we did brief the first 10 concerns to Elon. And then ever since then, our kind of funny fix was from now on, it's going to be the first 11, not the first 10, so that we know what's going on. But basically, we had a spreadsheet with concerns. We had people that brought up the concerns. What do we do against it? What's the estimate on how likely this is? And then what can we do in the long run? Yeah. And so we treated risk as something that you can mitigate in the long run. And then out of that came a system that basically, turned into a risk system.
Yeah.
And we would basically go through this for every launch. Not today anymore because there's so many launches. But initially, at every launch, you would sit together and say, these are the risks, and what do we have to do to make it safe?
So ultimately, what you're saying is that you looked at risk as something, like at any potential risk as something which obviously has the downside of that risk becoming reality.
Right.
But there's also a cost of fixing that, and you need to balance this, right? So it's always,
exactly.
And I think like that's oftentimes like being missed out, that everything has ups and downsides and you have to balance these, right? And nothing has only upsides without any downsides.
It's easy to say fix all the risks, but that's actually impossible. The really difficult thing is to actually weigh them so that you basically, for the time you have, for the money you have, you get basically mitigate the highest risks here. And just the assessment of a risk is really difficult too. Is this something that happens, I don't know, once in 1,000 times, or is it on this vehicle? That was always something that I struggled with. Like, I would always walk around the vehicle and ask it, what's your problem?
Yeah. And there are also so many non-linear connections of systems, right, where you don't know how they really will behave. And we read that you mentioned once that nothing replaces testing, right? And at SpaceX, actually, could you expand a bit on the company's testing philosophy to handle these risks, to develop, to iterate?
So, I mean, there's things on rocketry and aerospace in general that you can't test really or easily, like mostly attitude control related or guidance and control related, because you're in a different environment on the ground, right? You're just sitting there, you're not moving. And so you have to find ways to tell the vehicle, oh, you're actually moving, but pretend you're moving, yeah? And you can do this with like basically simulation computers and then run the vehicle so that it thinks it's actually running. And then it actually does something that, it would do in flight, depending on how well you do the test, basically. And that's called a hardware in the loop test. And it's a super important and valuable test. It shows you everything works the way you want it to. It actually sometimes shows you why it doesn't work like that. And so you get a chance to fix it without giving away that rocket for that particular knowledge. That's the test that I really believe gives you the most overall on a system level, basically. And there's also tests like on components, on how you test those guys. You shake them, you bake them, but those are more like workmanship things. I'm always interested in this big hardware to loop test and making that work. When you do that test, the last thing you have to do is actually you have to figure out whether plus means actually plus. So whether are you actually connected it the right way or not the wrong way, and so that you fix it the wrong way. So that comes on top of that. It's called a polarity test, basically. I mean, those are basically the main tests, and they're standard in the industry overall.
Yeah. And then, of course, SpaceX concept of reusing the rockets, landing the rockets. Right. I mean, every launch is also a big test, right? A full test, actually. How was that incorporated?
Well, so we pointed that out. I mean, there was really the fact that you get a rocket back and it has just flown that trajectory more or less. It means you have a pre-tested rocket, so flight tested rocket basically. And we pointed it out that that's actually a win here. And that's why reusability actually adds to reliability and makes it better. I don't think there was anything to really add, or we didn't change anything. We tested the rocket obviously when it came back, inspected it, and make sure that nothing broke along the way. And every once in a while, some engines need a little bit of work, but overall the majority of the hardware just stays just the same. Doesn't even get warped.
Yeah. And of all the things, so you actually, when you design, of all the uncertainties you have on the systems, right? When you launch and you lose the rocket, you will never be able to go deep. And it goes into both sides, right? So you can also save structures which were over-designed, right? And so this is what I think is really unique about your approach. And I have to say again, right, we will talk about the mindset, what we need to improve and learn in Europe over the US in a bit. But 2016 InnoSpace conference in Berlin, where Sven and I met, actually, there was Ariane people were on stage saying reusable rockets will never work. It's not going to be commercially viable. You have feared this potentially a lot, right? But they're really underestimating how you can use this to improve.
It was interesting because by that time we knew that you can actually do that, and it was not something magical. It was just like not really like an airplane, but we knew we can make this work. And then hearing obviously like these voices from Ariane that hadn't done this was a little bit like, okay, I'm not sure why you know this better, but you should at least keep an open mind. The lesson there is basically don't just be super careful with what you put on tape, because those videos of those conferences, they didn't age very well.
No, they didn't.
Right, you look at it today and you go, oh my God, this was terrible assessment.
Yeah, it's not that long ago.
Exactly. Definitely. Indeed, yeah. And this is bringing us to the next point. Like Sven and I, we think a lot about innovation, right? We are now a company of 120 people, so also not, again, like 10 people. And we have multiple teams, and we also want to keep innovation and pace, and we don't want to get slow, right? And I think you said like in the early days, right, being there before you were 10 employees, and you were there, let's build rockets, right? And you also mentioned once it felt a bit like NASA in the 60s, right? And I feel you when you say this, because in my master thesis, I was analyzing the drag in a low Earth orbit, and it was done by the mad scientists of NASA. All the papers I read for my master thesis were actually from NASA from the 60s, right? And these guys then thought, oh yeah, we're going to go to the next challenge, build a fusion reactor. A decade later, the program was canceled. So that's why nothing happened there anymore, right? And for me, it's crazy to see that nothing was done in the field. And the small group actually can change a lot. Can you somehow transport this feeling of the small team? And actually also, what do you think is a success criteria that a small team can out-innovate a company with way more resources?
I mean, we did actually have some resources in the beginning, right? We had a credit card. And it was interesting to literally start working a rocket with a credit card, because that's basically where it starts, right? You make phone calls and you buy stuff, and then you put it together and you make it somehow work over the next couple of months. But the first step is pretty, what's the right word? I mean, it's different from buying something at home, right? You just get something in and then you play around with it and you realize, oh, that doesn't work, or you're going to be smarter here. But it's like basically you're looking for people that are not afraid of doing that step without a lot of analysis, and basically get their hands dirty with hardware, put it together, make it work. It's funny. I just saw my notes from, I found my notes from actually. And in the first week, we were already talking about building a computer and running the gas generator with it in Mojave on the test site. And that was the first week. I mean, that's crazy.
Wow.
Basically within a week, and we knew really quickly what we want to do. It wasn't always the best thing, probably, but because it was fast, it was just what we needed at the time. The team, I want to say the team between, also Elon and the VPs, which was basically Tom, Chris, myself and the buzzer, was really, really good. When we missed something, we would just walk by the other cubicle and say, hey, I need help here, or I found this. What you want to change this to this approach rather, and we can save like a week. Everything was down to days, and everything was really, really dynamic. I want to say communication is a big thing. Elon was basically trying to remove all barriers to communication. So we all sat basically in one big room. We had no privacy. We were all sitting in cubicles. We all got cell phones from the company, and that was 2002, right? And so the idea was to connect everybody and just have them constantly work and talk on these problems, and it worked really well.
How did you keep this mindset when the organization has grown?
It's interesting in a way that it does trickle down from top down. So in other words, we would hire obviously people that have that similar mindset to some extent, or that can do that basically. And we would also make clear that, one of the priorities is that you communicate. You will not get an office with a door. We want you to be knowledgeable in all other disciplines too. You are basically your own system engineer. And it's not that you cannot focus on your narrow field of technology that you're the specialist of. You have to work with everybody else.
Yeah. Maybe very practical question to that, because you started when the company had 4 employees. Now it has around 13,000. At least it's what Google tells me. Right. So you've just mentioned at the beginning that you've hired so many people, and you just said that hiring plays a big role in keeping this innovation culture alive in an organization. What are your key tips for people hiring, which are hiring other people? Like, what should they look out for?
So first of all, you need to be super clear what you actually want. And in this case, we wanted competent people. We wanted people that are open-minded. We wanted people that go back to basic physics and not pick the solution out of a catalog from solutions from another company, basically. So we were checking actually people for basic physics, and we did some riddles. We basically asked them technical questions, and it's interesting because you would think that people felt a little bit like, oh, why I have a degree, why would I get checked again? Yeah, but people actually enjoyed it, and they did enjoy it, and they actually, some of them told me, oh, this is the first interview that really was testing my technical content, and I appreciate that because I've worked for this so long, and I became a little bit of a specialist in basically interviewing technical content after a while. I don't think I can do it again today, but I was checking, like, tell me what angular momentum is. Well, if you know that, what is nutation? Is that something that, happens on its own? Does it need energy? And then all these physical questions, basically, I would be okay if people say, oh, I don't know that. Yeah. But I'm more in this area, and then I would switch and try to work on that area. Yeah. At one point, you need to find something that people know. But we actually had, the reaction was really interesting. I mean, most people played along. Some people actually walked out. They would say, I don't feel like I should be tested. Yeah. And okay, bye-bye.
That's your choice. Well, I assume some of these people now regret their decision back then. But anyways.
Probably. I was really just like 2 or 3. I mean, it's just like very few.
We could ask tons of questions more on the really practical level, but we want to switch gears a little bit. So SpaceX obviously is famous for its vertical integration strategy, both with all its upsides and downsides. Now, you started with this in 2002, and since then you've vertically integrated a lot of things. By now, the space supply chain is obviously way more advanced and professionalized than it used to be. At least that would be my outside view. So what's your tip to companies which are starting right now? Should they still focus on vertical integration to retain speed, or is it now maybe better to focus on specific components?
We tried vertical integration at the beginning, but it wasn't very tall, the vertical part. So because there were certain parts we just couldn't do. We couldn't build a tank right from the get-go. So we ordered basically tank and domes from a company. Also, we basically bought a computer and put it together with additional parts. So we picked and chose basically what we would do. And then over time we expanded that. And it also depended a little bit on the company. If there was a company that actually was good and relatively cheap and was actually working with us on that, on making things cheaper, great. I don't think that actually happened. That's the downside was most companies have their own agenda, basically. And that's the fundamental problem, right? In really, when you buy just aluminum or whatever, fasteners or something, that's totally okay. They can have their own agenda. I just need their raw material, and that's it. But if you're trying to have a more complex, let's say you buy a flight computer and then you need firmware, then it gets a little bit touchy, because then you find actually eventually out that, the firmware has bugs and it needs to be fixed. And then the company says, no, we're busy with this other thing. And so for the more complex something is, the more I would pull it into my own supply chain. And the more on the bottom it is aluminum or so, where I have more than one vendor, the more I would be inclined to do that, frankly.
Okay. Interesting. And now you're currently advising also several space startups. What common challenges do you see these companies facing? And what advice are you giving them regarding fundraising, but also technology development and building teams?
And product strategy.
Yeah.
So it sometimes depends. I mean, I'm very specific on some of the stuff. I do work, the three main ones, or four basically, are last building a space station, Stoke building a reusable launch vehicle, back to that again, and Astroforge building a mining satellite, and then OHB on the board and environment. And they all have their different challenges, basically. So it's kind of like, I don't think I can say something generically there, other than I like it when companies have urgency. And when you come in and you feel the need that you're behind, right?
Yeah.
You got to work today to catch up to the goal. And I think that's really, to me, this is really important to be productive. In general, if I know I'm late, then I focus on the stuff that I need to do. I have no time to chit chat. I work as hard as I can. And by the end of the day, I might be hopefully a little bit closer to the goal, right? If I come in and everything is relaxed, and so I might as well go skiing. I mean, it has to be some urgency. And so I'm trying to make urgency in those companies. Most of them have them anyways. I mean, it's, that startups in the US, the fundamental problem also is money at the end of the day.
Yeah.
And so they have urgency, because if they're not quick, then they're going to run out of money.
Yeah. It's also the same for European startups.
True. It's actually harder for European startups, I want to say, almost.
Yeah.
Because it's really hard to get the money. The environment is not quite as friendly as here to startups. Regulations are more. And so I totally believe that it's actually harder for European startups.
Yeah, that doesn't help Sven and me. We are still doing what we are doing. But I can see you. And actually, it's a good transition to our next point, because you, in 2013, you said once you've used your German accent to establish confidence, saying, for example, this will work. It sounds convincing. And as a German who worked at maybe the most exciting company of these days in the US, but comes out of Germany, worked in German companies, right? You experience a lot of different cultural environments, right? And engineering approaches specifically. So first question regarding this topic, did you have to evolve to the US, or did you see that the US people were saying, let's do what the German engineer is doing?
No, I had to evolve. I mean, I did change. I changed over time too. I want to say I was a little bit, I had like a very strict way of working things. Yeah. And I realized I can jump over my own processes and get faster to the result. In many cases, I don't care on how pretty it looked, as long as the, whatever the main tests have been done. And so I think I changed more than I changed other people, but I did always brought the element in there of personal responsibility. When you build hardware, you're responsible for the hardware, and you better know your hardware. So if I ever come and have a question about your hardware, I want you to be able to really answer that. Because that was my job, basically, right? If I assess the risk, I need to know, how much risk is in your hardware. Yeah. And so from that perspective, I was always strong on that. And I don't know if that's a German trait or not. For me, it was just like something that we had to do to be safe for astronaut. It's actually interesting too. I did see that German companies changed too, right? So my vision, a work environment is something where you can say your concerns and that's all okay. Yeah. And it turned, when I look back now in Germany, it's like everybody's trying to be nice and polite and whatever, yeah? And the real problem actually is rarely touched upon. And SpaceX was always a company where you would say, well, I need your status, but I don't need the good stuff. I need the bad stuff. Yeah? Okay. And I really liked that. That was kind of basically how I thought German companies work anyways. It turns out that actually German companies don't work like that anymore.
Yeah. Yeah, you mean you need to be straightforward, and you have to. But I think you have to foster this, right? It's not something bad. I don't try to be negative.
Exactly.
I just want to be here as effective as I can be. Yeah,
exactly. Because you don't need to work on the stuff that's good, yeah.
yeah.
And then you have meetings and people tell you what good stuff they did over the last week, and you can summarize that. And I appreciate that, and you get your shoulder slap, and that's great. But I really care about the stuff that went wrong last week.
Yeah. And it's also a lot about like conflict handling, right? When you talk about these tough points and that you go out of the comfort zone. Yeah. And what Sven and I have seen also in the past, I don't know, like 2 years. I mean, you're also in the supervisory board of OHB, right? And I had the feeling you were somehow coming from the US, understanding the German ecosystem or the European ecosystem in a bit, right? So.
I have to say, yes, I did recognize certain things in the German ecosystem, but at the same time, I also saw how it changed. And so I saw that, and this is not OHB, but I actually worked for a couple other companies, so I saw it somewhat decline, and not as innovative as it used to be, not as not what you expected from German companies, basically being, always trying to say we are world leaders and this and that, and actually not being it. Yeah, so. Things changed a little bit in Germany, and I think actually German companies need to sit down and work hard on catching up with other companies.
Yeah, and maybe that's a great transition to our next question, which is, what is the role of Europe in the space sector? Is the race already over for the old continent? Because honestly, if we look at Starship, we had the question is, okay, good, what's left to do for us here? What's your view on that?
So there's two aspects of that. One of them is obviously satellites are closer to the user. So Europe is still strong on the satellite front. They can still build excellent satellites, and they can still contribute to space technology on the satellite side. Yeah. On the rocket side is necessary to get there, and it is strategic. I feel like on the rocket side, work needs to be done. People have been sleeping on the helm, basically, for a long time. I think actually ESA recognizes that. I really appreciate understanding the difficulty of that. It's a difficult situation overall. I have to admit, I wouldn't quite know what to do myself in a way other than this. Let's start from like a piece of paper again. Yeah. Because it is a very intertwined system of industries trying to build something, and it does need basically a fresh start, in my opinion. There's efforts going on in terms of trying out reusability, but the time span of these tests is just too long. It has to be part of ongoing projects. Yeah. Basically, it needs a little bit of a reset and the urgency that I'm missing in many projects and on the European side.
Yeah. But then what you're saying is maybe, okay, rockets, launchers, it's going to be a strategic point of view to having our own sovereign launcher, but commercially at least likely competitiveness will be difficult to maintain. But on the satellite side where you need to be closer to the user, that's maybe a field where Europe can still play a strong role, correct?
Right, exactly. I do feel like Europe has still a foothold on the satellite industry in general, and is still doing excellent science, excellent science satellites. So that part is still working, although I could probably use some overhaul too. But on the launcher side, I want to say the race is almost over. It's never quite over, but there will only be reusable rockets in our future. It's just like the cost of an expendable is just not bearable anymore.
Yeah. So it's interesting.
There's a lot of things that actually will change, and Starship is probably just one of that. That's probably worth another hour, almost like what's likely to happen. Yeah, but I'm pretty sure things will change. Things will be very different, and the space industry in 10 years will look very different than the one 10 years ago.
Yeah, but this is an interesting one because you now say Europe focus on the users, on the satellites. And I met Tom Müller actually a few weeks ago in Paris, and thanks to Bud and Altan, and actually in a bar, right? And then I realized, so he was the first employee of SpaceX, and he started Impulse Space, which is now actually the next wave of in-space transportation, right? So while Europe is, like you say, Europe should do the bread and butter satellite stuff, the former SpaceX employees, they start own companies and do the really heavy stuff now, right?
It's somewhat heavy, but at the same time, it's also a narrow focus, right? Once you build that product and can run it, that's pretty much it. Satellites don't quite work like that usually. But Tom obviously recognized that the bigger, like Starship, basically launching 100 tons, several of these 100 tons want to go in a different direction. And that's what he's using.
Yeah. But maybe touching on the point which you've opened before, where do you think the space industry will be in 5 or 10 years? What will happen over the next 5 years? What will this paradigm shift of Starship enable?
Well, if you drop launch costs significantly, well, okay, here's the problem. The launch costs don't necessarily drop with one reusable vehicle. They drop with two reusable vehicles. You need competition. And because otherwise, there's no need for it to go more than $1 under the next vehicle. And so there needs to be more competition just to get the price really down. Then you can launch heavier satellites. You don't need to actually engineering the lightest fragile satellite that you can possibly have. But you can basically fly a container and just mount the stuff on the wall of the container, basically. And so that, or on the telescope, just fly the mirror the way it is on the terrestrial telescope, and don't worry about trying to make it light. There will be definitely changes on the satellite industry. I hope the satellite industry actually responds to that, because I found the satellite industry really, really slow in some of these aspects too.
That's true, yeah. So we know you have a hard cut. There's one question I really wanted to get out because as a Trekkie, space and time, you know that sometimes it feels weird. And when you go back to the first week, you just found your notes from the first week, right? Back then, like fasting forward to 2024, did you thought back then that SpaceX will be there where it was, or already with mice on Mars?
No, that would have sounded preposterous. I mean, that would be a crazy thought that we would ever dominate the launch industry. First flying astronaut is a crazy thought in 2002.
So faster and way bigger than you could have imagined.
Oh yeah,
and you had big ambitions already, right? So that's yeah.
I don't think I had actually. That's a German thing too. I don't think I had really big ambitions. I thought like building a rocket and going orbital on a rocket is like a really big deal. And it turns out actually not that
from today's perspective.
From today's perspective, yeah.
Amazing. Well, Hans, it was a great conversation. We learned so much, and we could talk for hours here. But we have one final question which we ask every guest on the podcast, which is, who should we bring on to the podcast next?
Right. Well, I think a good person to talk to is Sabine von der Recke. And she knows the landscape pretty well in Europe, and also what needs to be done. So I think she would be an interesting person. Have you talked to Helene Ubi?
Yes, she was on the podcast.
Yeah. Okay, she was right in there. Yeah.
Amazing.
It's not a person.
Well, we're gonna make sure that this podcast will be recorded. But Hans, thanks so much for spending this hour with us. I think we took a lot from it. I hope our listeners did so too. Thanks again. And if
well, thank you.
And if you're interested to learn more about the new space ecosystem, make sure to check out our other episodes or follow us on any of the socials out there.
Yeah. Thank you very much for this opportunity.
Thanks a lot.